Hello everybody, this is Rudra Pradhan here and welcome you all to BMDA course. And today our discussion is on descriptive analytics, and in the previous 3 lectures we have discussed details about the descriptive statistics, then the concept of association kind of structures, and then we have discussed probability. So, the idea is that the descriptive statistic and association statistics are very handy to solve some of the business problem and to get some kind of managerial implications, or you are in a position to take some kind of management decisions. So, now here in the last lecture of course, we have discussed something called as probability, and probability is one of the typical requirement of any kind of complex problems so far as business analytics is concerned. So, now in the last lectures, in fact, we have discussed details about the probability, the concept, rules, and the kind of features and requirements, and here we will continue this probability concept and then connect with some kind of distributions, because we have actually lots of distributions, and your analysis or your predictions and the kind of management decision is concerned. So, you have to see what actually the data or your informations exactly, that to in what extent and that to what behavior altogether. So, in totals you are supposed to know what is the typical distributions your information will be lying. So, once you are in a position to detect, then then you may be in a position to analyze properly, then accordingly you can come to a conclusions. So, before we connect with probability distribution, so some of the concept I like to highlight here. So, the first concept is actually random variables. We have already discussed what is exactly variables. Now, here the concept is called as a random variables, and it is a numerical descriptions of the outcome of an experiment. And a discrete random variable is one for which the number of possible outcomes can be counted, and on the contrary, so there is a concept called as a continuous random variable, where the outcomes over one or more continuous intervals of real numbers. So, now a probability distributions will be featuring of the possible values that a random variable may assume, along with the probability of assuming these values. So, these are simple kind of understanding. So, in the kind of structure, so we like to actually connect with the random variable, discrete random variable, continuous random variable, and the concept of probability distribution. So, now we will start here like this. So, first of all, discrete and continuous random variables, and let me first give you some kind of connections that to highlight some of the examples under the discrete variables and continuous random variables. So, like the previous examples, outcomes of dice rolls, whether a customer likes or dislikes a product, number of hits on a website linking today. Then examples of continuous variables will be weekly change in a kind of structure, daily temperature, time between some kind of machine failures, time between two different kind of policy change. So, these are the typical examples through which actually you can understand the kind of discrete random variable and continuous random variable. So, accordingly your distribution will be connected. So, once you understand the particular variables, whether it is a discrete or continuous, so you can apply the discrete probability distributions, or you can apply the continuous probability distribution. So, that means typically what we have discussed earlier, so frequently which we are highlighting every time, that if your understand problem understanding is not clear, whether with respect to the concept, with respect to concept, or with respect to technique, or with respect to data or variable, something like that, then you may not be in a position to address the problem or analyze the problem as per the particular need. So, obviously, so your requirement is you have to understand the problems and its kind of requirements in a kind of attractive way, so that you may be in a position to solve the problems as per the problem requirement. So, now with the particular example which you have cited earlier, so now this is the outcome of two dice, and then what is the kind of probability which you have already discussed earlier. So, in the earlier case we are actually targeting a specific case. So, that means when two dice will be rolling, then what is the sum. So, it may be starting with 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and earlier we are targeting a particular case. So, now in the distribution, so far as the distribution is concerned, then all possible outcomes you have to cite, and corresponding to each possible outcomes, so what should be the probability. So, that is the difference between probability and probability distribution. So, that means probability distribution followed the kind of all possible events subject to the corresponding probability. For instance, this is the case of dice rule case, and here so the sum will be starting with 2, 3, 4, which we have already discussed in the last discussion, and then corresponding to 2. So, this will be 1 by 36, because the frequency will be 1, here the frequency will be 3, again here the frequency will be also 3, then again the probability will be 1 by 18. So, that means actually, so it is a two different case, 2 by 36. So, this coming actually 1 by 18. So, like that so it is better you can first put the possible outcomes and number of frequency, then individual case divide by total frequency. So, that means every times you can keep actually down 36, 36, 30, so that you should not have any kind of confusion. So, now if you plot, then the plotting will be exactly will be coming like this. So, it will be look like a kind of distributions. So, this is a probability distribution of roll of two dice. So, this is actually the x axis will follow the value, that is the sum of outcome, and then the chance of occurrence, that is what the probability all about. So, this is the standard example of probability distribution. So, now corresponding to this this particular case, if you move further, then we have already discussed this particular concept, the computer repair times. So, now I am again plotting this same So, here in the case of probability distribution, all the possible outcomes need to be plotted. Then the idea is you have to check how these actually outcomes are, and that to which distribution it follows. So, depending upon a particular distributions, then you will apply the prediction rule as per your problem requirement, right. So, accordingly this is another example here. So, then corresponding to this change situation, then the availability of probability, once you plot, then obviously it will also follow a kind of probability kind of pattern, and this again if you connect, this will show you some kind of distributions. So, now likewise so here the idea is how probability can be connected or to create a kind of distributions. So, this is how you have to understand, and then again, so there is a concept called as probability mass functions. It is a kind of mathematical function, and represented by f of x, specifying the probability of the random variable x. So, that means x will specify the particular case, that means x I represents the ith value of a x. So, we have a number of cases. So, I may be moving from 1 to 10. So, then you will find what is the probability of x 1, probability of x 2, probability of x 3 up to probability of x 10s. So, the cumulative probability distributions, So, you like to find out individual kind of probability, then finally you have to find out cumulative probability. So, now if you cumulative probability means you have to add 1 by 1, then finally if you will follow up the probability principle, then the finally you will get sum of the point will be exactly equal to 1. So, that is what actually the total probability. So, that means technically we have already discussed earlier, the value of the probability will be 0 to 1 and in between 0 to 1 and the total probability will be exactly equal to 1. So, this is also applicable here in the case of probability distribution, and then accordingly you have to analyze the kind of business problems. Okay, so, same things. So, earlier case we are actually using P. So, here we are actually using probability mass functions by citing f of x, and depending upon x change. So, you will get a kind of probability structure, and if you plot, then it will give you a kind of distribution. So, that particular structure is called as discrete probability distributions. In the case of continuous probability distribution, the structure is a little bit different, because you need to cite the kind of interval structures, right. So, let us move to that particular concept. So, here is the kind of a structure called as cumulative distribution function. So, probability of rolling between 4 and 8, right. 4 and 8 means, so so the idea actually here. So, so this is what actually the representation P, so x is the kind of requirement, and that too in between 4 and 8. So, we have actually 2, 3, 4 and 8. So, this is how the kind of structure we need actually this much. So, then so P 4 8 means, so probability of 4 minus probability of 8. So, f of x equal to 4 and f of x equal to 8, then you will get the particular probability again. So, this is actually some kind of microspecific kind of requirement. Again, so probability of 3, probability of x, which is between 3 and 8. So, that means this is the case, this is the case typically. So, 13 by 8 minus 1 by 12. So, this will give you the value of probability 23 by 36, right. So, likewise actually, so the probability mass functions will give you some kind of overview to understand the concept of probability. So, now we have already discussed mean and variance, standard deviations. Now, probability, through probability distribution you can also calculate the mean, variance, etc. of this particular series. So, when you are playing the particular game, then the possible outcomes will be coming one after another. So, that means all possible outcomes are known to you, corresponding all possible outcomes. So, you have actually probability. So, now so that is what actually called as sample sample points. So, now corresponding x and you have a frequency or probability. So, now in order to get actually a mean of this particular distribution, or mean of that particular series, or variance of that particular series, then you have to just connect with x upon the corresponding probability, like example, a cited example is what we call as weighted mean. So, now this probability is nothing but called as a weight factors. So, now corresponding to x entry, then you have to find out what is the corresponding p. So, it is something summation pi xi. So, for a particular situation, so what should be the probability, then all possible cases. So, if you add up, then by default we will get kind of concept called as average of this particular series. Here we call as a concept called as a expected value of x, and this is nothing but summation pi xi divided by summation pi, that is actually sum of the frequency or sum of the probability. Since sum of the probability is exactly means exactly equal to 1, and that is always true. So, obviously mean of this particular series will be summation xi f xi only. So, this is the cited example here, and the particular concept will be like this. So, this is what the kind of structure. So, you will continuously move up to a particular situation, then finally you can calculate the kind of mean of this series, right. So, similarly you can actually calculate the variance of the series, and okay. So, I will show you in details in the Excel sheet. So, here expected value of a not element, this is specific actually examples, and like these are possible cases, and what is the expected value of this particular series, and obviously connect with the probability, then find out the expected value. It is nothing but actually what we call as mean occurrence, and the variance will be by default will check the volatility part of this particular series or distributions. So this is what actually another way of citing this discrete probability distributions. So cost of this particular ticket is $50. Then corresponding to this the information, so you have to create a distribution. So these are all called as x possible situation, and this is the fx possible situation. Then you have to find out the mean of this particular series. So means like what I like to submit here, that this is a standard kind of structure through which actually you have to generate a distributions, and once you get a distributions, then in order to address further, you have to find out the average of this particular distribution, variance of that particular distribution, and if there are two such kind of parallel kind of structures, so then you can also connect with association, establishing the association kind of concept, and that can help you to predict the kind of business problem or business environment. This is another kind of typical examples through which actually you have to predict the particular environment. Here simply actually a number of cases and then corresponding to probability, and you have to find out the mean of this particular happenings. Then with the help of mean of the happening, so you can predict the particular business environment. This cited example is here the kind of airline revenue management. So you have actually ticket cost and ticket price, then what should be the expected probability of selling full fare tickets, so that your business will be at the highest levels. So these are the typical example which you can follow, and what I have already mentioned. So you can calculate the variance of this particular series. So the kind of example which you have cited, so this is actually x occurrence, and these are all corresponding probability. So just you have to multiply, then you will get x of fx. So this will give you the kind of mean of the x series. If you sum all together, then you will get a concept called as expected value of x, and the difference this is actually standard variance formula which we have already discussed earlier. Here only thing is you have to connect it with this probability concept only. So then ultimately, so you will get a variance factors. So now with the value of mean and variance, you can actually predict the particular situation. So for instance, if you are predicting a particular business, so the mean should be high and the variance should be low. So now a different situation you have to apply accordingly, and then you have to follow a kind of structure. Okay, so this is okay. So after knowing all these kind of probability and probability distribution, then we will go by specific case. So we have actually couple of cited examples, starting with binomial distribution, then Poisson distribution, normal distributions, exponential distributions, uniform distribution. So that means actually having the informations and the corresponding probability, you have to typically follow how is this particular concept. So this is actually Bernoulli distributions, and here so it is nothing but actually the concept of probability of success to probability of failure of a particular event, right. So so this is the concept where binomial distribution or Bernoulli distribution is concerned, and then accordingly you have to calculate the mean of this particular distribution and variance of this particular distribution. So that means once you have a probability distribution, then in order to predict the particular situation as per the requirement, you have to report the mean and variance, and with the help of mean and variance, you can get to know what is happening and what should be the kind of future strategy. So likewise we have actually a similar kind of examples. So these are all actually cited examples which will be connected with Bernoulli distribution, and I am not going in details, but I am directly coming to this binomial distribution structure, where the particular structure is followed by NCX px 1 minus p to the power n minus x. So here this is actually c is missing here, but actually it is a NCX. Then this 1 minus p is nothing but called as q. and P plus Q is nothing but exactly equal to 1. So, P is the probability of success and Q is the probability of failure. Then the distribution will follow like this. So, x upon a binomial distribution. So, that means the structure will be exactly create a kind of strategy through which you can understand how is this particular game altogether. So, like this you have another distribution called as what we will call as this is what is the typical example of binomial distribution. I will take you to the Excel sheet and show you how actually it is coming all together. This is very simple actually. So, n c x p to the power x q to the power n minus x means you have to just see the probability structure, the individual requirement and the kind of sample requirement, then accordingly you have to find out the probability. That is what actually prediction structure altogether. So, let me first highlight all these distributions, then I will take you to the spreadsheet and show you how these actually coming and what is the kind of probability or prediction strategy altogether. And this is how the what we call as Excel spreadsheet. You have to just follow this particular structure to get the kind of distribution patterns or the kind of probability requirement. It is exactly the probability distribution, but it will follow a particular patterns. For instance, in the binomial distributions, so you have to fix the numbers, then the trials, then the probability, and then you whether you are looking for a particular case or you are looking for a kind of cumulative case. So, accordingly, so you have to find out the particular structure. Okay, this is an example of binomial distribution, and again it will follow a patterns. This is what actually probability distribution together. So, that means whether you are using the binomial distributions or Poisson distribution or exponential distribution, obviously you have a x occurrence and the corresponding probability. So, the probability may be following actually binomial kind of structure or exponential kind of structure, uniform kind of structure, like this So, depending upon the kind of game, it will be actually having a kind of difference. So, we like to check what is the kind of difference altogether. So, this is another kind of example of binomial distribution, and another distribution is called as a Poisson distribution. So, here so the number of occurrence in some unit of measures, and there is no limit on the number of occurrences. Here the average number of occurrence per unit is a constant, and that is denoted by a structure called as lambda. So, now the probability mass functions for this Poisson distribution will be this one, and again with the specific parameters value you can actually predict the particular environment and create a distributions. So, again we will highlight in details in the Excel spreadsheet. So, let me complete this one first, then we will move to the. So, this is the details about the Poisson distributions, and this is the classic examples through which actually you have to apply the kind of Poisson distribution and to predict the particular environment. Okay, so, again so this is the kind of structure which you can follow in the case of Excel spreadsheet to predict the particular environment. These are all x occurrence, and these are all corresponding frequency, and this is corresponding cumulative frequency. And then this is the classic example, another classic examples, that is pricing strategy for Kimpton's hotels on price line is models using a Poisson distribution. The number of bids placed per day 3 days before arrival. So, actually so depending upon the parameters value, then the prediction will be like this, and accordingly it will give you the kind of probability about 11%. This is another kind of structure called as continuous probability distributions, and in the continuous probability distributions, so your probability will be lying between two different intervals. So, that is why here the structure will be probability of a less than equal to x less than equal to b, and standard example of this particular distribution is called as uniform distributions, and the probability density function will follow like this, and corresponding to this one's unit distributions we have actually. So, this is actually same expected value and variance, means whether binomial distribution or Poisson distribution or uniform distribution, every time corresponding to the x you have to use the mass function and create a probability structure, Then once you create for all x, then this will create a distributions, and then you have to report the expected value and variance, and in order to understand the particular situation, and then you have to predict as per your requirement. So similarly, this is the classic example of uniform distributions, followed by uniform distributions. So okay, so this is the exact structures we will follow in the uniform distribution, and then I will take you to the examples. Okay, so this is the actually the kind of distribution which you need very frequently for any kind of business analytics. That's called as normal distribution, and it is a bell shaped curve, and understanding is with respect to two parameters, mu and sigma squares, that is called as mu mean and variance sigma squares. So usually the normal density function will be followed by a kind of structure where it will show you the series kind whether it's a symmetric or kind of skewed. So in a kind of normal distributions, usually the structure is symmetric, and where mean, median, mode will be coincide, and in fact it is a bell shaped, and the end part of this particular curve will be typically called as asymptotic in nature. So the usual structure of the normal distribution curve will be like this. Okay, so this will be the kind of structure. It will be asymptotic, that means it will be parallel to x axis in both the sides, but it will not touch. So that is how it is called as unbounded, and through confidence interval you have to predict the kind of probability depending upon the particular situations. Okay, so let me give you the kind of examples which you can actually use in the case of normal distribution. This is actually we have discussed earlier, corresponding to kind of the discussion on descriptive statistics, where we have pointed out the shape of the curve or shape of the particular spreadsheet. So whether it is a symmetrical or skewed, whether it is a right skewed or left skewed kind of things. So normal distribution give you better structure through which you can project the particular environment. Okay. This is a continuous probability distribution case, where mean and standard deviations will be given. Then with respect to a particular requirement, you have to calculate the probability, right. So likewise we have and this is what the typical structure about the normal distribution case, and here you have to calculate the individual probability, and then you have to connect with cumulative probability, and these are the typical examples or specific through density function you have to calculate the kind of requirement. Okay, so this is what actually the kind of continuous process. So so again I will take you to the Excel sheet and show you how exactly it will be coming. Okay. So this is a typical feature of normal distribution. Obviously in any kind of distributions, so the feature will be remain same. So the probability will be positive, and it will be follow a kind of pattern, and if you add up all the individual cases, then the sum will be exactly equal to 1, whether it is a binomial distribution, whether it is a Poisson distribution, whether it is a kind of uniform distribution, or whether it is a kind of normal distribution. So the principle is almost all same, but you are supposed to actually, these are all specific different kind of cases through which you have to observe the particular structures. So let me take you to the particular example, then I will show you how actually it works altogether. Okay. So now see here, so I will take you to the particular case, let us say binomial distributions. We have already discussed the case of binomial distribution. The probability mass function will be nc x p to the x n to the q to the power n minus x, and then accordingly you have to calculate. So let us say that x is a random variable, and the x structure will be followed by like this. Okay. So let me little bit make it big. Okay. So see here, so the in the binomial distribution the parameters are n and p. So this is a sample kind of case, and this is the probability value, and here if you put actually this is actually binomial distribution. What will you do here? You just put actually, let us say I will just show you how it is actually coming. So, let us say this is actually put equal to signs, then you put actually binomial kind of distribution. So, by default binomial distribution will be coming like this. So, it will ask you to put the numbers, that is n, which is nothing but actually a 10. Okay. So, this is actually this is actually no, this is okay. So, let me start once again. Okay. Okay. So, this is actually, yes. So, here actually variable description is required. So, binomial distribution. So, this is binomial distribution, just put double click, then the variable actually here the requirement actually number means this particular number, then put actually a indications, then the trials will be 10 here, then probability will be 0.2 here. Okay. So, then you have to give actually whether you need actually particular probability case or you need a cumulative. Let us say first you start with the probability particular case. Okay. Click there and then close the loop and then enter. So, this will be for x equal to 0. When x equal to 0, then probability a normal binomial distribution case, the probability structure will be 0.11. Then if you drag down, then it will be generated for all the x. Okay. So, this is actually remove this one. So, this is up to 10. So, this will follow a kind of distribution. So, now if you need actually cumulative structures, then again you go to the binomial distribution and then you click here, then you first indicate the variables, okay, then followed by the trials, that is actually n 10s, then followed by probability, that is 0.2, and then so you need actually a indication about the false, right. So, we have already requested the false case, now we are reported the a true case, then you just scroll it, then you will get actually this is what actually called as cumulative frequency distributions, and this is what actually the Excel spreadsheet will help you to calculate the binomial distribution corresponding to the parameters availability, where n equal to 10, p equal to 0.2 and x is a random variable which moves from 0 to 10, right. So, it may be any kind of business problem, but the kind of prediction will be follows this kind of structures. Okay. So, now corresponding to the binomial distribution, you move to the kind of Poisson distributions. Here the Poisson distributions just against you go to the Poisson distribution, put equal to signs, then instead of binomial, so you put actually Poisson distribution, then you just double click again, then it will ask you the x value. So, that is nothing but actually these random variables, then it will ask you to calculate the report the mean value. So, the mean value is given, that is 12 here. So, put here 12, then again, so it will ask you the false case and true case. So, that is nothing but the frequency and the cumulative frequency. Let us say put false case, then close the loop and put enter. So, it will give you the kind of probability. Okay. So, this probability is with respect to Poisson distribution. So, now this will be generated, and this is the case of false. Again, so the same structure, if you go by true, then it will give you the cumulative frequency. So, again you put Poisson distributions. Okay. So, click there, then indicate the variable choice first, then put the mean, that is 12. Okay. Then put actually the true case. Okay. So, then you close the loop and then enters, right. So, this will give you the kind of indication about the cumulative structures. So, now means so this is how again Excel spreadsheet will help you to understand the Poisson distribution depending upon the values of the random variable x and the mean of this particular parameters, right. Again, so you go to the normal distributions, In the case of normal distributions, again same things, here you have to you report the two parameters value, mean and standard deviation, and the variable specification. Again, so I have actually specified here the range of random variable x. Again the same structure, you put actually equal to sign, and then you put actually normal distribution functions, and here normal distribution by default will be coming. So, just click it, then indicate the variable description here, then give the indication about the mean, which we have already specified actual 750, and again so specify the 750 and specify the standard deviation, that is actually 100, and then you specify the kind of a particular requirement, that is you put actually false, then close the loop and enters. So, this will give you the specification. Okay. So, here actually it is better to put true, because in the case of normal distributions we need actually cumulative distribution. So, you write here true, okay. Then you put the enter. So, it will give you the total probability under different situations, right. So, this will be generated like this. So, this is the case of normal distributions. Again again you go to exponential distribution case. Here the parameter is lambda, and the again you go to this kind of put this particular structure, then you ask for exponential distributions, and then exponential distributions. So, put here. So, the requirement is actually variable indication. Again first you put the variable indication, then the parameter value. So, the parameter value is here 8000. So, here the reporting will be 1 by 8000, that is as per the probability mass functions requirement. Then the kind of false indications, then you just close this loop. So, this will be coming like this, okay. This will be coming like this, okay. So, these are the kind of examples which you can cite in the case of various distributions. So, that means, so what I like to say that Excel spreadsheet has a lots of advantage, which I have highlighted earlier, that we can predict the business environment, or depending upon the particular situations, or particular available informations. So, now in this case we have discussed various probability concept and various probability distributions to know the kind of requirement and to predict the particular situations. So, that means actually once you acquainted with the particular structures, whether it is a kind of case of binomial distribution, or in the kind of Poisson distribution, or in the kind of normal distribution, then once you will be acquainted with all these concept and the kind of requirement and the kind of problem, then obviously Excel spreadsheet will help you a lot to predict the particular environment. So, here the only requirement is you have to understand the particular probability, and that to probability distribution, and then corresponding to a particular problem situation and the requirement. So, use this spreadsheet, and very quickly you can get the output, and once you get the particular output, that will help you a lot to predict the business requirement. So, this is what we have actually discussed all these things. So, I am once again reporting how this is the case of exponential distribution, which we have already highlighted, and again if you will plot, then the nature of the curve will be coming like this. So, this follows a distribution pattern, and that particular distribution is called as exponential distribution. Corresponding to binomial distribution, Poisson distribution, exponential distribution, normal distributions, we have actually so many other distributions, and here again 3 more specifications are there, triangular distributions like this, log normal distribution like this, beta distribution like this. So, that means actually in the kind of business games, you like to know how is the particular business structure corresponding to the particular information and the business structure. So, you like to check how the distribution it follows. So, depending upon the particular requirement and situation, you have to apply a particular distribution and predict the environment as per your requirement. Okay. So, now So, in this unit actually we have discussed various concepts of probability and the rules of the probability, various theorems behind probability, then probability distributions, and we have discussed something called binomial distribution, Poisson distributions, exponential distributions, and normal distributions. And I have already discussed how these distribution can be applied, and what every distribution followed by a particular mass function. And once you know the mass functions, and if you know the advantage and disadvantage of a particular distributions, then accordingly you can apply, because for a particular distribution the requirement is specific. Once the requirement is fitted or available, and depending upon the situation you can apply that particular distribution and predict the particular environment. The idea is here in this probability concept, that means you have to actually predict, or you have to forecast what is the chance of possible kind of requirement. So, ultimately since it is a kind, initially we have no idea what should be the kind of feasibility, or what is the kind of particular choice. So, the particular distribution and the particular concept and the particular structure will give you some kind of output through which you can take a decision. So, that means it will give you some kind of certainty from the uncertainty environment. Initially you are not in a position to predict, or you are not in a position to apply any kind of strategy. So, now with the help of probability and probability distributions, by using either binomial distributions or Poisson distribution or exponential distribution or normal distribution, you are in a position to predict the business environment. So, that means actually before you go to any kind of management problem, so I am very sure 90% of the problem, minimum 90% of the problem, it will be for, fitted under some kind of distributions, because it is a kind of data generating process, and then obviously with the help of a particular problem structure and the kind of problem requirement, you have to fit the particular distributions, and then accordingly you have to predict the particular environment. So, the idea is that until unless you understand the concept, so you may not in a position to predict. So, again the summation is that you have to understand the problems, and understand the concept, and then connect the concept with the problems, and then you predict as per the requirement and the need. So, with this we will close this particular chapter, and then in the next chapters we will discuss with the sampling and sampling distribution, which is actually well connected with this probability and probability distribution. And whatever concept we have discussed here, starting with the binomial, Poisson, exponential and normal distribution, same distribution can be again analyzed in the sampling and sampling distribution, where the situation is just opposite. We have to create a kind of background and samples with the help of this particular distributions, right. So, that we will discuss in the details in the next class, and we will stop here. Thank you very much. Have a nice day.